So the value of a polynomial is used to determine the value of a second variable y. Then we have a polynomial function, right? If we have a variable, in this case, like I said, y equaling a polynomial, right? And so that's a polynomial function. We've dealt with polynomial functions before, right? We've talked about linear functions. And so that's where you have a first degree polynomial. And so, right, y equals mx plus b, that's a polynomial, usually a binomial there with the first degree, okay? And y is usually our output variable. All right, then we also have function notation, which we've dealt with to some extent, where we have, in this case, p of x, right? So remember, that doesn't mean p multiplied by x, that means p as a function of x. So x is the input and p of x is the output. And so if you see something like this, find p of -2, what it's saying is make -2 your input, set x equal to -2, right? And figure out what the output is. And so basically you just plug in that value and then do the operation that's happening, right? So here in this case it would be x squared, so we'd do -2 squared, right? And then we take away 1. So we just do the operations to whatever this input is and then evaluate that. Okay, so in this case, -2 squared would be +4, and then 4 minus 1 would be 3. So p of -2 equals 3. All right, so notice that we're not doing anything with this side of the equation, with the left side. We're just evaluating the right side with this given input, right? So that's how we evaluate functions. All right, so here's another function, q of x, right? That's a polynomial with 4 terms, and it's a 4th degree polynomial with a leading coefficient of -3, right? All right, so let's try an example. So evaluate each polynomial as indicated. So let's try number 22. So here it says evaluate this polynomial, trinomial, right? 2nd degree, leading coefficient of 3. And we want to evaluate it for x equals -2. So all I'm going to do is I'm going to rewrite this polynomial, except instead of an x, I'm going to put a -2. All right, so that's how we set it up, is we just put -2 in wherever there was an x before, right? And I usually put them in parentheses, especially when you have negatives. I think that's a really good idea so that you avoid sign errors. All right, so now I can just use order of operations, right? So -2 squared, that's exponents first there. So that would be +4, right? -2 squared is +4. So now I have 3 times 4. I can deal with this negative, turns into a positive, +2, +2. So then I can multiply next before I add in. So that 3 times 4 is 12, +2, +2, and 12 plus 2 plus 2 is 16. All right? So that's how we evaluate polynomials. So number 24, we have a fraction involved. So x equals 1/3. So what I'm going to do is I'm just going to rewrite this polynomial, right? One thing you can do is just rewrite it with parentheses wherever there was an x, right? And then whatever this input value they give you, you can just put that in, right? So I'm going to put 1/3 there and 1/3 there. So wherever you have an x, you put in the value they give you for x. And so once again, just order of operations, we're going to do exponents first. So 1/3 squared, 1/3 multiplied by itself is 1/9. So it'd be 3 times 1/9 plus 1/2 times 1/3 minus 1. And so 3 over 1 times 1 over 9 is going to be 3/9, right? Which can be reduced to 1/3. All right, then we have 1/2 times 1/3, which is 1 over 6 minus 1. All right, so here it looks like we want a common denominator of 6, right? So I'm going to multiply 1/3 by 2 on top and bottom. So that gives me 2/6. And then 1/6. And then with 1, I'm going to put it over 1 and multiply by 6 on top and bottom. So we get 6/6. So we can add all those together. And we get 9 over 6, which reduces to 3 over 2. So that's our answer. All right, let's try number 28 to see function notation. So for number 28, they're asking for p of 2. And so what that means is input 2 in for x, right? They're saying the same thing as what we said in these other ones, except for now it's just using different notation, right? It's kind of an easier way to say, instead of 4x equals 2, you can just say find p of 2. And so p of 2 equals, it's x cubed plus 1, but instead of the x, we're going to put in that 2. Okay, so you put a 2 in for where x was, and now you just evaluate it just like we did before. So 2 cubed is 8, plus 1 equals 9. So p of 2 equals 9. All right, and remember, once again, we didn't do anything with the left side of the equation. We just evaluated the right side of the equation. So that's how function notation works.